All right, guys. Thanks for joining us on what we are calling season 2, which I think, Dan, will be much easier for us to remember what episode we're on again, since this is now episode 1.
Okay, that's true.
We don't have to worry about such a high count any longer. So thank you for joining us. We are excited to be here. We've got Bob with us today. He's our product manager, and he's going to chime in on some of the exciting products that we have to share with you today, which we've already announced, but this is going to be a little bit more formal and let us talk specifically to the technology.
Right.
So if you've joined us in the past, you know all of the existing tech talks are available on the YouTube channel, which is Baseline Web Training. All one word on YouTube, Baseline Web Training. And Dan continually adds to the library on YouTube. So check that out regularly. And if you're interested, you can catch all of season 1,
right,
Tech Talk Tuesday on YouTube.
That's right. And in the break period, Dan has continued to record content and is having it on the same channel under Ask the Trainer, correct?
Right. So you get a chance to submit it. There's a place where you could submit a question. I'll answer it within a week. Everyone gets to see the answer on YouTube. You can look through the previous questions I've answered. Really simple questions, or sometimes just something that's bugging you and you just want to know the answer to.
Awesome. All right. So what do we got for content for episode 1? I'm just eager with anticipation.
Tipping rain buckets.
What?
So, tipping rain buckets. Let me cue this up, right? So
Baseline doesn't have a tipping rain bucket. What are you talking about?
Not yet, but it's close.
Okay. Hold your breath there. Okay.
Very close.
So, anybody that is in charge of managing irrigation, if we're irrigating when it's raining, it makes it look really bad and it's a waste of water. So, people sometimes might go online and shut off their controllers, or worst case scenario, they're going to drive around to sites and shut off. And that's probably the easiest case for getting rain data and finding out what's going on with precipitation out in the site. But what if you want to know more about your rain events? What if you want to know about how much rain or for how long did you get rain? Right. That's what we wanted to talk about today, was how to up your water management game with tipping rain buckets and soil moisture sensors. So that's why we brought Bob Beers in from the product team, and we're going to talk about an upcoming product release. So awesome. I want to start off with the first question for Bob about tipping rain buckets. So now that tipping rain buckets can integrate into 2-wire systems, could you tell us 2 things? I have a 2-part question. So could you just do a real brief description of what a tipping rain bucket does? And then why is it so important? Why should we care about it?
Yeah, for sure. So I think a quick distinction between the rain bucket itself versus, say, a rain switch is when you're looking at the rain bucket, it's a rain collector in a sense, to where we have the can. Inside the can body, internally, there's a small kind of lever action that's flat. And then each time it collects rain in a rain event, it's going to tip. And that tip creates a closed contact switch that the decoder, our 2-wire decoder, very similar to a flow decoder, can read those pulses. So each time that switch closes due to contact with rain, it's able to measure that. And it's a highly sensitive instrument in that it can read up to 1/100th of an inch precipitation rate within a minute. And so we're able to capture that data each time that lever pulses or closes due to a rain, contact with rain. We're able to measure it, both rate, and then over time, we can measure the volume that it has captured. So we can capture that information on a minute-by-minute basis with the 3200 and log it. And then we can display it to you to show you the previous hour's worth of rain that we've collected at that site. So we can show you the rate of rain precipitation, and we can show you the volume of collected rain at that point at your site. And so being able to get that resolution of precipitation rate and volume data versus kind of a simple switch. So it sees rain and it turns off, and then you don't get anything else. You don't know how much it rained, for how long it rained. And that provides us, that extra data gives us a lot of extra flexibility for system automation. And then to your point, for additional site management functionalities that we can implement for tracking over time, and then being able to share that information with critical stakeholders.
Yep. So that was going to be my question was, tipping rain buckets have been a part of central control and water management for years. What makes the tipping rain bucket interface unique with the Baseline technology?
Excellent. Yeah.
Yeah, I think there's a couple of different things that we're able to implement with Baseline. I think it's exciting. First is our start, stop, pause capabilities with the 3200 and with Baseline technology. So being able to automate your system with data from the tipping rain bucket device to inform how a program needs to behave based off of the data captured by the rain bucket. So we can start irrigation and or start programs based off of a rain event specified by duration or volume captured.
Wait a minute. So usually you want a rain bucket to stop or to pause irrigation. Why would you want to start irrigation with a rain event?
Yeah, surprisingly, in some instances, it could be to save water and actually be more efficient. And we can discuss that. But it's also to maybe offload a rain catchment container, so you can initiate a pump evacuation sequence. So if you need to unload some water because you know you're going to overfill it, then you can start a program to offload that. But on the efficiency side, when we're looking at a soil profile, and part of the reason why we have soak cycles with the 3200 and with Baseline technologies is we know that first initial cycle is going to help induce capillary reaction in the soil profile. And that means that the subsequent cycles in irrigation is going to get better, more efficient penetration into the root zone. And so being able to initiate an irrigation cycle after a quick rain event, you're going to be able to get more water more quickly into the root zone.
You're definitely talking next level water management, which is impressive. It's
which is
not
exactly what Baseline does, is next level water management. So,
right on. That
brilliant.
Can we get that on shirts? Because I'd go for that.
Sure. You can buy a shirt and put anything you want on it, Dan.
That's right. Now, Andy, we were talking about this yesterday, that idea of that information for other stakeholders. What do you want to?
Yeah, so I got actually a couple comments. Number one, I want to remind our audience sort of what makes this all possible and sort of the technical sort of capabilities in which we're able to collect this information. So you've heard us talk before about our 2-wire technology. Yes, it turns valves on and off. Yes, we send power to the solenoid. However, what really makes it unique to market is our ability to transfer data back and forth from the field to the controller, from the controller to the field. And so you may have missed what Bob just said about this rain can being able to be connected to the 2-wire path. So you can locate it anywhere on your project. It does not have to be physically wired to the control box. You can put it anywhere on your 2-wire path. And that really unlocks a lot of advantages in terms of being able to locate it in the right location on your site. So just keep that in mind. We're able to send that data back and forth. And that's kind of what powers our technology, is that transfer of data from the field to the controller. And, sort of what we were talking about yesterday, I asked Bob sort of a pointed question about sort of why, why did we come up with the rain can?
Yeah.
Of all the devices in the world that we could create, invent, and bring to market, how did this rise to the top? And we had this great discussion about collecting data and using data in a water management perspective and for water savings. And what's really interesting, and I think all of you joining us today can relate, you could go install, let's say, smart equipment, Baseline and or other. You could replace nozzles and sprinklers and create the most high efficient sprinkler system out there. And the next season, you could use more water, right? What? If next year it is a drought, you could use more water.
Yep.
Now, your client, who's not as educated as we all are, will just look at the water bill and say, hey, we use more water this year, but we spent $75,000 investing in this equipment.
Yeah.
And so the rain can is sort of like the way to create for lack of a better word, that baseline where you can look at your water savings potential as it relates to rainfall to know how you're doing, right? Or maybe that rain event happened once. We got 3 inches of rain in one event instead of 1 inch of rain every 3 weeks. So there's a lot of great information that you can pull out of the rain can to see how your system's operating and performing.
And to be able to tell that tell the story about your site.
Yeah, and it's sort of we sort of coined without coining. Rain is the reason, right? Rain is the reason we use more or less water. If the system is as efficient as possible, rain becomes that reason.
Nice. Awesome.
Yeah. And then, to your point, Andy, being able to capture that from the field. So the 3200 individually can sync up with up to as many as 8 different tipping rain buckets at a single site. Wow. If you needed to. So we know in some areas along the Gulf Coast and in Florida in particular, we encounter very specific hyper-localized rain events that could be on one side of your property, but you don't experience on another side of your property. And by being able to implement more rain buckets across your site, you just get better resolution into the behavior of rain events that you might be experiencing.
Yeah.
And
so
then,
that lends to a question that's come in. How many of these rain cans or tipping rain buckets can we have associated with the controller?
Yep. So up to 8 per controller.
Now, I might be able to have a substation and have that connected to a substation, and that is one of the 8. So that if I had zones scattered across, I could have them. Well, we can also have 8 substations. Imagine that. Wow.
Yeah, I think it's a great extension of another great use case for the substation technology and the wireless 2-wire that's supported by the 3200 to substation extension of that 3200 capability. So spreading out the geographical influence of a single 3200 using substations, and then being able to use the tipping rain buckets in conjunction with that. So I think that's a great point, and it's a great use case for both technologies. And then what's cool about another kind of little tidbit with Baseline that Andy kind of touched on with the bidirectional communication from devices in the field to the controller is the decoder itself is going to collect and remember all of that data by itself and send it to the 3200. So you have additional backup storage data at the decoder level. Then at the controller level, if you're connected to Base Manager and App Manager, then the 3200 will send that log data that it's collecting every minute to Base Manager so that we can expose that to you in Quick View, as well as in the analytics tool in App Manager. And then you can also place these different assets so you know exactly where they're located using the map in Base Manager.
Bob, can you say that one more time about the decoder? Did I hear you right when you said that the rain data is stored in the decoder?
Yeah, exactly. So the decoder itself, it's kind of like a mini computer out in the field where it's collecting the data, tracking it, and logging it. And then when the 3200 requests data from the decoder, it's that bidirectional communication you talked about. That's really kind of one of the main differentiators of the Baseline 2-wire technology. That decoder sends that packet of information that it's stored already to the controller. And so we have multiple points in the overall system architecture where we're collecting and storing data and then submitting that up to the cloud so we can expose it to users so that you have more ways in which you can use that data.
Yeah. And this is a good time for me to have a shameless plug for users of Base Manager. Let's start in 2020 fresh, or 2021 fresh. And rather than logging in directly to basemanager.net, log into baselineapps.net, right? And that'll give you access to the full App Manager suite where analytics is located in the left tile menu so that you can view this data and interface with it and report on it and export from it, et cetera, et cetera.
Yeah. So go ahead, Bob.
Sure. And I was just going to kind of continue the conversation of what we can see on the screen where we have 3200 decoder, rain bucket, and we also have a moisture sensor on the screen.
Yeah.
And so why are we integrating this moisture sensor into our conversation with tipping rain buckets?
Yeah, show us all the products that are part of this new product.
Yeah, so what we're thinking is there's different ways in which we can deliver this product solution to market. And so customers would be able to purchase the decoder directly, or you can buy it as a kit where we have an integrated solution where we send the rain bucket decoder kind of pre-assembled, ready to go out of the box. And then we have a third solution that we're calling our kind of Tipping Rain Bucket Pro, which includes a BL5311 mini compact moisture sensor. And the reason why we're putting this together is we find that there's a lot of value in being able to correlate moisture data in the soil profile near where the rain sensor is located, giving you better resolution into the effective rainfall of a given rain event. Because we can measure the total usage of a rain event, say it rained 4 inches, but what did that actually influence within the profile itself? So being able to directly associate that location and that locale of the rain event with the overall soil moisture profile that we can measure, log, and expose in Base Manager and Analytics and App Manager gives you a lot more story to tell when we're talking with stakeholders and telling the story of your site over time. And that's kind of the example that Andy had provided earlier, where you might have a month and where you have 3 inches of rain in a single month. The year later, you also have 3 inches of rain, but how was that rain distributed over time in that month? And then you'd be able to see that directly on your moisture sensor graphs because we're tracking that data. So you can see a big spike because we dumped 3 inches, and then maybe we hit capacity. Now you got runoff, and we're able to track the volume of the rain event, and we could see that we hit soil capacity, and we didn't actually get the benefit of full 3 inches. Whereas in the following year, we might have, because we had multiple events that added up to the same 3 inches, but spread out over multiple weeks, and then we could see the infiltration rate, and we could see all of that in the moisture profile where we have the wet down and dry down cycles.
Yeah, I think the key takeaway is being able to measure that effective rainfall.
Right. Yeah.
Right. And the effective rainfall is going to be optimized when you reach and don't exceed field capacity of that soil profile. So if we can measure how much rain fell and even be able to suspend or stop irrigation from happening in the future because we're at that field capacity, or after a rain event, we can add as much water as needed in order to optimize that rain event and get to field capacity in our landscape.
So since we're talking about soil moisture sensors, and this is something that we hear this frequently, is I've already got a soil moisture sensor. Why do I need a rain shutoff? Why do I need a rain device? And I think it's a valid it's a question I think we want to address.
Yeah, absolutely. I mean, I've seen this, teaching soil moisture sensing technology for 15 years. You get in front of a group of, not you all here as audience, but you get in a group of novices, and their first sort of thought is, oh, moisture sensors, perfect. Now I don't need a rain sensor anymore. And it's really important to think about the actual job of each piece of technology, or what each sensor is actually best suited for and where it should be located, right? So when we call it a soil moisture sensor, that's because it needs to be buried in the soil. And a rain sensor is a rain sensor because it needs to be up in the rain. You want to put the device where it can sense what it needs to sense. And so if you think the soil moisture sensor is going to shut off in the rain event, it might. However, it may take an hour or 2 or 3 or 4 for that drop of rain or multiple drops of rain to reach the level of the sensor. But if you put the rain sensor in the air, it can shut off as quickly as you set it to shut off. Yep. And so that's, an important consideration, is that you do need both, and they each have a specific purpose and have a specific task that they're good at.
Yep. And having that go ahead, Dan.
My example that I've used when I do training in the classrooms is I take a 5-gallon bucket of water and I dump it on the clay soil that's here. How long is it going to take? How much that is going in the ground? How much is running off? How much is reaching the soil moisture sensor? Just exactly to Andy's example of we need to measure it, place it where we're measuring it.
Yeah, and with the tipping rain bucket's resolution of down to 1/100th of an inch, that likely isn't going to penetrate the soil deep enough to get to the get to the moisture sensor. So there's going to be rain events that the tipping rain bucket will be able to capture, log, and track that maybe due to evaporation. You're not going to see it at the moisture sensor level every single time.
And Bob, what was that? Can you repeat that sensitivity level?
It's 1/100th of an inch.
And at that sensitivity, can we pause the program for 1 hour? Is that possible?
Correct. Yep.
Okay. So thinking about a traditional rain sensor with the discs and the minimum thresholds is what? 1/8 of an inch?
Eighth of an inch, yeah.
So a 1/100th of an inch is like just a little bit of almost mist in the air that condenses and drops on the seesaw paddle that tips it. So you could use this. It's highly sensitive. If you do not want it watering in the rain, the tipping bucket is like almost an instant off, it sounds like.
So here's a real nerdy use case that might work, and I'm anxious to try this out in the field.
Oh, I was wondering when you were going to go here, Conger.
You know, I'm just waiting, right? The nerd in me is like, oh, wait.
All right.
If I put this out in a turf application, just set it on the ground, connected it to a controller, and ran my irrigation, I could use this to verify a pretty damn accurate precipitation rate. I could figure out my coverage, right?
Exactly. I think that's a great use case.
Yeah. 8 of them.
Yeah, sure.
Pattern.
Yeah.
Brilliant.
Yeah, given that the main requirement is that it's connected to your 2-wire path. I mean, if you want to lock it in at one location, remove it, take it over to another spot, and just to validate your precip rate, just so you know that your system's set up to optimize its overall functionality, I think that's a great use case for the technology.
Yeah, that bodes another great question that came in. We keep talking about it on 2-wire, but will this work with the conventional wire system as well?
At this implementation, it's not going to direct connect to the R boards. The moisture sensor would, because we have the valve or the moisture over valve technology with our R boards. But the tipping rain bucket will interface directly with what we're calling the BL5407 decoder only.
Yep.
And now, Bob, it won't interface with the 2-wire port at the controller?
And it could do that too.
Okay.
Right.
So, yeah.
It will. You just can't wire it to the conventional wires and have it read where on the controller.
Right. So I'd like to
dedicated 2-wire path from controller to 5407, which is connected to the rain bucket. So and since
like
our flow sensors.
Yeah. And since each R board has a 2-wire terminal on it, even though it has conventional wire, we could extend a short piece of 2-wire to run that. Maybe it's going to sit at the controller, or maybe you can get your 2-wire path further than that, but it will need a dedicated 2-wire that could come back to the R board or to a 2-wire controller.
Yeah, like Chris said, exactly like our flow decoder or our flow sensors.
Yeah.
You know, they're 2-wire devices, and remember, every device on a baseline system is a 2-wire device.
Nice. Okay.
Yeah, great question.
So I'd like to kind of come back to start, stop, pause a little bit. And so to stop, start, pause is for me was always one of those really powerful aha moments when I met Baseline, was the ability to start a program, stop a program, or pause a program. And difference being, a pause means it's a temporary stop. It's going to resume again once the condition changes. So we could stop. So stop and pause. So those are two basic ones. So we get a certain amount of water, or what are the two criteria that we could have? So I want to stop my irrigation when it rains a certain amount, or when it rains so much over a certain period of time. What are those parameters again?
Yeah, so there's really two main ones that the 3200 is going to look for, and that's going to be rate. And that's rate by hour that it's going to measure, and it's going to log it similar to the flow decoder every 15 seconds and then log it at the minute level. So it's going to go out and talk to that decoder every 15 seconds when we're operating and track that data. And so as it's collecting the pulses from a rain bucket during a rain event, it can understand and infer the rate of rain based off of that precipitation event. And it can also track by volume. So you could say, if I see 1 inch of rain per hour, shut me down. That's exceeding my.
So it's a heavy rainstorm that we got 1 inch an hour. That's shut down.
Yeah. And you could be okay with, well, it's only 1/10 of an inch. And it's like, well, that's kind of more of a drizzle. I don't need to shut down irrigation for that. I feel comfortable with that operating. Or it could be by volume. So, hey, over the last 60 minutes, I've seen 1 inch of rain fall. I really don't need to irrigate anymore. I feel comfortable with this. I feel good about it. Part of the value of getting that kind of resolution and that system automation could include things like, or a use case like with establishment zones. So you might need to get water down for a new turf area and establishing some new turf. With a rain switch, you might shut down 2 minutes into your irrigation cycle, and then the rain event can stop a minute later, just after a brief drizzle. And now that area of turf is going to have to wait till the next program start time to be able to get irrigation. With the pause functionality, you can set those parameters directly. So you can say, even if I get 1 inch, I still just want to get water down in this area so we can still run. Or pause me for 5 minutes or 30 minutes, and then let's go back and look at where we're at. Okay. And so it just gives you a lot more fine tuning for different areas of your site and different implementations for irrigation.
Nice. So what does that look like in the programming aspect, Bob? Because that sounded pretty involved. So how complicated is that to set up in the controller and program it to do that?
Super easy. Super easy. It's really just 2 fields. So it looks very similar to any of our other 2-wire devices and sensors with start, stop, pause capabilities. So moisture and temperature, it really looks and behaves just like that in the controller display and in Base Manager. So it sounds sophisticated, but it's really only a couple fields, and it's just understanding what the site's requirements are and what you feel comfortable with.
Yep. And keep in mind, it's a program specific device. So if you have some programs that you want to, disobey the rain can, that's totally possible. Or maybe some programs that aren't even irrigating.
Awesome.
Something else.
Yep.
Nice.
Very cool. All right. And then what about calibration? Will this device need to be calibrated periodically?
Nope. So the 3200 will read it, and it doesn't behave like the moisture sensors will have calibration automation. So you will want to check it occasionally to make sure debris hasn't fallen into it. You'll be able to understand or see that. And you'll still get similar 2-wire diagnostics. So if there's a no connect, it's not getting any data back. Is it a 2-wire issue? Is it a decoder issue? The decoders all have these will have the LEDs built into it as well. So you can do blink tests. You can go physically look at it. You can look at the wired connection from the decoder to the rain device itself. And then you can make sure and look at that the rain bucket doesn't have any debris that's fallen into it that's impeding the sensor's ability to tip.
Okay. And is this unit compatible with the 1000 as well?
It is not. So for today and for our upcoming launch with the device, the devices that we have in the field currently for testing, it's a 3200 only. Next phase will include the substation compatibility, and then a future potential is the 1000. But for today, it's just the 3200 only.
Awesome. All right, that is a lot of information in a short
it's
amount
cool.
of time.
It's cool technology.
Yeah.
So Andy's point, like, why are we doing this? There's a lot to be excited about.
It's the year the Baseline's doing its rain dance. We're gonna make
rain is the reason.
Rain
nice.
is the reason.
Awesome.
Love it. All right. Well, we're at the end of our time. Believe it or not, 30 minutes into season 2.
Put 4 nerds together and they're going to kill a half an hour.
Enjoyable for everybody.
Cool. Thanks for having me on.
Yeah.
But we appreciate your input.
Right.
For sure. We're going to make you a more frequent participant. How's that?
Sounds good.
Yeah. So with the new season, it's Tech Talk Tuesday. So we anticipate, as we're still in kind of shutdown mode, winter mode, if you will. I know it's not the case for the southern markets, but we'll continue to do these weekly with content. And then we may, when season launches, make it every other week or whatever, but it'll always be on Tuesday. So we want to make sure that we've got, informative content for you on a regular basis, that it's meaningful, that you walk away learning something. And then we also want to make it a bit more dynamic with more guest speakers, maybe some more field reports and site visits as COVID land allows us to do so. So we're looking forward to the new season, and we appreciate you all joining us. And it's glad to have you back and share with you Baseline technology. So
yeah. And feel free, if you're working on something that's pretty cool that you want to share with us and with the group, reach out to us. We'd love to hear what you're working on and how we can not only help you, but maybe use what you're working on to help some other people too. So
that's right.
Feel free to reach out.
Make it an episode. Yeah. So, all right, everybody, go out, work hard, be safe, have fun, and we'll see you next week.
All right. Have a great week.
Thanks, everybody.
Bye.
Bye-bye.